I'm taking a letter from the mailbag and it says, "Dear Mr. Kirkton, we did the practice test, me and my friends, and we said we don't understand this problem with those quadratics. What are them? They're quadratics. Will you please help us? If so, put on a video on YouTube because we'll watch it." Okay, so I will help you. So first of all, you notice it's the first question on the test as well as this one. Um, they're just trying to see here, do you know how to substitute? Do you understand what this function notation means? It tells you it's quadratic. That means it's going to be x squared somehow. And it says p and q are positive integers. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bigger than that. Calculate the value of q. Okay, so we know one thing. We know it passes through the point 6, 0. In these problems where they give you a weird function, they just gave you x and f of x. So substitute f of x, or y, equals p times 6 and q minus 6. Because x is 6, y is 0. So 0 equals 6p times q minus 6. It says calculate the value of q. Well, to make this equation true, q would be 6. And you can distribute this if you want, but it's already in nice factored form. Basically, it's a different way to factor it. So q is 6. It says the vertex of the function is 327. Okay, so what do I know here? I know q is 6. So I'm going back up to my original value here. So f of x equals px 6 minus x. And I'm looking at, what do I know? I know the vertex is 327. So I know that an equation y equals ax squared plus bx plus c is a quadratic. And I know the vertex is negative b over 2a, opposite b over 2a. So I'm just going to keep that in my mind here, and I'm going to figure out what can I do. Well, I can still plug in a point. The vertex is 327, so that's an x and y again. P times 3, 6 minus 3. So now I have, this is 3 times 3, 9p equals 27. That means p equals 3. So now I have improved my equation a little bit more. And so now I know that p equals 3 and q equals 6. So I go back to my original function, f of x equals, it's px, so p is 3. So 3x times q minus x. Q is 6. 6 minus x. That's just going to be a nice old quadratic. 18x minus 3x squared. Okay, so let's check and see if our answer matches up. I'm going to write it in order. And let's see if the vertex really is this value. So vertex x equals the opposite of b over 2 times a. That would be 3. If you plug your 3 back into this equation, f of 3, we're going to see if it's equal to 27. So negative 27 plus 54, positive 27. So you're kind of answering an Algebra 2 question in a roundabout way. The whole key to doing these point problems is where they give you some points in a weird function. Take this point and remember this is x, y. This is x, y. It's taking care of 2 variables. We had 1, 2, 3, 4 variables. If you take care of 2 of them, you can do a lot of solving. Okay, and the last step says write down the range of f. Well, there's a couple ways you could do that. We now have an equation for f. You could just graph it. negative 3x squared plus 18x. I know the vertex is 327, and so I make this graph, go, man, I'd like to change my window, and say, oh, wait a minute. They had me find the vertex because the biggest y value is up here at 327. So that means the range is y must be less than or equal to, or f of x must be less than or equal to 27. If you like to use interval notation, you could say 0 to 27 that way, or negative infinity to 27. These mean the same thing. You might want to change that to f of x. Okay, so key to this, plug in points. Hopefully that helps with a little bit of them there quadratic reviews.